Okay. So welcome to Geostats. Last week I was in, or I just got back like 11 o'clock last night. I was in Puerto Rico. So does anyone know what Puerto Rico is? What is it? Is it an island? Is it a country? Is it a state? What is it?
Territory of the U.S. island.
The territory of the U.S.
Territory.
Territory. So why do they have their own Olympic team? So, but like other territories don't, right? Why not? So they have, the deal.
Be subject to the guilt.
Oh, definitely, they definitely are. And,
Say the size maybe?
I think with the Olympics, it's more of the Olympics determined they were separate enough for them to be their own, their own team. Because I kind of like it. I'm kind of resonates with me a little bit because a wrestler placed at the Olympics, bronze medal, and he's from New Jersey. He's from the same town as Dr. McGinn, one of our professors, and he's going to be a coach at my old university. The kid, but he's probably never really set foot in Puerto Rico, but his parents are from there, and he couldn't play. He probably would have trouble placing for qualifying for the U.S., but he finishes ahead of the U.S. guys, which is kind of funny. You know what I mean? Even though he wasn't quite as accomplished as the U.S. guys, but it's kind of depends on having a good day or whatever. But I thought it was neat there. What language do they speak there? Spanish. So why do they speak Spanish if it's like U.S. and it was kind of colonized by the Spanish? It was kind of interesting because this workshop I was at I was basically on like the colonization, more specifically like decolonialization. Which I thought was kind of interesting because, we all these folks that go down to Puerto Rico and guess what language we're all speaking? English, because like we're the only ones, yo puedo hablar un poquito español, but no one else, speaks it, anything. So we go down there, we show up and we're all speaking English, so everyone there has to learn our language and we're sitting in their country. And so some of the decolonization of science, science and particularly serving Hispanic students. But it was Columbus, his second voyage to the quote unquote New World. It was in Puerto Rico, so they have this big sculpture. It's like 110 meters tall, so 360 feet tall to like Columbus, where Columbus was just some guy who basically just kind of took, like, hey, this is mine, when there's already lots of people there. And there was slavery was a big component there, which wasn't even outlawed until 1860s. And so there's a real rich, Hispanic, African mix of folks there, but it's run by like the United States. It was previously run by Spain. Spain really isn't that much better. And then we got it in the war, Spanish-American War of 1898. And so, Spain there was a little bit of Britain kind of get a foothold of it. And so I thought that was kind of interesting. So we kind of have it right now, because we want some influence in the, Caribbean, because at the time it was like Spain, not a lot of US going on there, you know what I mean? But yeah, Germany, even Denmark has, influence in there, and then France and England with, Guadeloupe, Grenada, St. Lucia, Montserrat, St. Kitts and Nevis, some of those are territories like Guadeloupe. Is it Guadeloupe? Is that the island? Yeah, Guadeloupe. Are you familiar with this area, Philip?
I speak French.
Oh, okay, you speak French. Are you from down there?
I'm from Grenada.
Grenada, okay, good, all right. So I'm gonna refer to Philip for all of this. Okay, sorry. Grenada, that was English, right? All right, so. Okay, that was after the French and Spanish. So I want to refer to Philip here because I only pretend I know what I'm talking about just from the few days that I was there. But the U.S. wanted some influence in there until we had Spanish-American War, which that was a good time to get some influence there. And then we got the Philippines there, so we have really big influence there. And then the Danish were there, and then I think they were scared of losing Puerto Rico, and so we went and literally like bought country from Danish. What's it called? What is the actual country and islands that we bought from Denmark? U.S. Virgin Islands. Yeah. Like a lot of people, like I remember Trump, he was talking about buying Greenland. Remember he was talking about that, let's just go buy Greenland. Who does Greenland belong to? Or, Denmark. We did it 100 years before. We were just like, hey, Denmark, we want your land here. Can we buy it from you? So it's kind of funny, like they make fun of him, but we've done it before in 1960. Who was that? Wilson, I think it was. And so U.S. has some influence down there. And so is Grenada still part of the Commonwealth? Didn't one of those countries just recently leave?
Yeah.
Okay, I thought one country just left the Commonwealth, Barbados maybe, one of those countries just left the Commonwealth, so kind of really, interesting influence. But I talk about the idea of decolonization, because they use kilometers and we use miles per hour and all those other things there. And we're going down there and we're speaking English, even though everyone there speaks Spanish. So I thought it was really neat, how do we kind of decolonize science and, scientific literacy as well, because, all these units, what do I use? I use miles and square miles. We got people that have to sit here and convert them all from acres to hectares to square kilometers and all these other things. And how do we, and more specifically me, be more receptive to the units that everyone uses? We were talking about this PM, what is it, grams per meters cubed, but I'm sure we got a unit sitting here. I don't know what it is, but it's probably some type of English unit, and it's like, ounces per cubic foot that we've all kind of converted. So it was really neat. It's really hot. So I'm sure Grenada is even hotter, warmer, but it was like in the 90s and people are walking around in pants. And I'm like, I'm not wearing pants. I don't care if it's a meeting, I'm not wearing pants. And it was just so hot. And I go running. So I went running in the morning at like 6 and it's like 80 degrees out. And there were people out before that, but I just couldn't wake up very early. But really neat, really interesting. If you have an opportunity, we're part of this grant, so we're hoping to take some undergraduate students, some graduate students down there. To Puerto Rico, it's a 3-hour flight from Charlotte, so it's relatively close, and it's like kind of another piece of America that you're not really you get to see, you get to see. And so I went running. There's chickens and dogs and kind of neat, stuff that you don't really necessarily see here in the United States. But I thought was, really interesting and just really rich food. Like none of this hamburgers and food, just a lot of plantains. And I love, love bananas and plantains and everything. So it was really neat. But take advantage of the opportunities. It's called GeoWit. So me and Dr. Malter are putting together a grant to do some work with the university down there in Arecibo. So if you see some opportunities for those, take advantage of them, because we always like taking, different people. I don't like taking Andy to every single thing because that only helps Andy. You know what I mean? We want to kind of spread the wealth a little bit. And so, and this January, I'm taking a criminal justice student to a transportation conference. So we're really trying to expand our majors a little bit. And then in March, we're going to a GIS conference and we're taking, some of our online students, trying to get them exposure because, with our online program, it gets to be very kind of students just sitting there. We want them to really be, part of the program. So that's it. That's about it for this week. So I'm still a little beat here. We're not going to have homework this week. So really try to finish stuff up. If you haven't turned in exercise 2, turn it in. Usually my policy with late work is it becomes late after I grade it. So I'm going to go and grade stuff. It's not sitting in my grade book when I grade it, whether it's 8 o'clock tonight or 10 o'clock tomorrow, whatever, it's late. So even though the deadline said it was late, it's not fair for me to have it required at your time when I'm not going to do it until I feel like doing it. You know what I mean? It's hypocritical, to be honest with you. And so it won't be late until I until I start grading, And usually that's the day after or whatever, but it'll be other days. Someone pointed out that I had an incorrect due date. So for reading number 1, it's not due until next week. And so exercise number 2, just make sure you get that in. Those students who are kind of relatively new to GIS, I'm obviously going to give you some grace with exercise 1 and exercise 2. And then exercise 3 is just going to build on exercise 2. And then I'm going to call them 3A and 3B because we're going to cover different sets of skills when we talk about normalization. Then, I'm still playing catch up from some things. So if I haven't responded to any specific questions, I apologize. And I'll kind of work on those. But the readings, I think I posted the reading on, was it elections? Yeah, which one? Oh, food access, yes. Debunking the urban myth. So, debunking the urban myth and all that other good stuff. So that used a lot of descriptive statistics. And largely what we did was we're in that summarized too. And so I just started to pick out, urban food desert, urban not food desert, rural food desert, all those other things. And then I ran those summary statistics and I'm pointing it at the folks here because this is what we were just doing when, as part of one of their lab rotations in data science. So we had these big table, we just started running these summary statistics, the mean, the median, the mode. And in our cases, things like population, the sum, total population living in food security across a couple of thousand census tracts in North Carolina. And so those are some neat, basically that's what I did. So today we're going to talk about normalization. Hopefully I always say this, but hopefully we're going to get out a little bit early because I do want to kind of look at some of the raw data here, but we're going to talk about normalizing data. And those of you taking some of the in the PhD classes, you're going to notice some things and ask some bigger questions here, but we're going to talk about joining data. You already ran a spatial join, and what we're going to do later is run a join here. Today, we're also going to run something called a join. We're going to run something called a summarize. Summarize counts the number of times something appears. That to me, summarize is a really powerful tool so that I can make GISE or what we call geopotential data. So when I run the join, it's a popular functionality to give tabular data spatiality. And my skill set is having big data sets and putting them onto a map so we can do things. How are we going to make GIS data? In our lab rotation, we're working with about 5,000 records of PM. We went to the Air Now data that had air quality index, parts per million, parts per megaparts per micrograms per cubic meter, all this other stuff here of about 5,100 records. And then we've gotten to a point where now we're just looking at about 22 different stations from those 5,100 records. But we've also collected metrics of measures of central tendency, mean, median. I don't think we captured the median with those, but also measures of dispersion like range as well as standard deviation. And so when we went and run a join, we're working with really neat tabular data that we want to give GIS coordinates to. And what they have and what we need is something called a key. And so a key needs to be unique and non-repeating. And one of the challenges that we work with these large data sets, and I'm sure the folks that we were just working with before, they notice is that, hey, there's a lot of repeating latitudes. Like, how am I going to distinguish this record from this record from this? Well, you can't really distinguish those unless you want to do something really kind of ugly or nasty. And Daniel and I last week were looking at this like long time series climate data stuff that he's going to go and download and make some sense out of. Like, you got a latitude, you got a longitude, you got dates, you got probably 20 different columns. I don't know what they mean. The PM data that we were looking at probably had about 15 different columns. Some of those made sense, some of these didn't. Some of these are going to be qualitative, some of these are categorical or quantitative. So how are we going to make sense out of all these? And that's where we earn the big bucks as a kind of GIS professional. So when we join data, typically joining data is you've got a cool Excel or CSV file, and I want to make a map on it. Someone just sent me one from across campus. I guess I get to do that tomorrow or something. And so typically we have an attribute table and a standalone table. And folks that we were talking about, kind of refer to them a lot, is that the attribute table already has existing relationships with GIS data. So if we have 100 records in an attribute table, there's going to be 100 features on the map. With a standalone table, that's not necessarily the case. So when we opened up our, PM data, we had 5,166 records in that table, but there weren't 5,166 points sitting on the map. That would be a really ugly map. I'm going to get really ugly really quickly. So we ran some summary statistics to kind of parse that down into 22 using those summarize functions. And that kind of where we sat. And so here we're looking at a CSV file or some standalone file. These were like helmet laws by state. We had a student who used to ride motorcycles and he wanted to map all the helmet laws by state. And so we can run a join that says, hey, here's my standalone table. Okay, yes, I'm sharing my screen. I just want to make sure I'm sharing my screen. Here's my standalone table. Let me just add this standalone table to the end of my attribute table so that I can do my queries and selections and everything. But a lot of neat things or a lot of interesting things need to happen. And so I can just add this to the end using a join. We're going to run those joins today. You're going to run a join. You're going to run them with me. And then you're going to kind of just finish up the homework for the first couple of weeks. And then we're going to kind of reset next week and get into some more advanced statistics. Because today we're going to talk about normalizing data, kind of answering those no-duh questions, meaning, of course that makes sense. When we map death rates, we're basically mapping where the old people are. And so how do we circumvent that? How do we vet those? And so this is my brand new attribute table that I can map here. So I can now make a map of helmet laws by state instead of it just sitting in some nice, pretty CSV, Excel file or whatever. And a lot of these data that we see sitting over here, whether it's SIDS deaths or ulcerative colitis or ADHD, or in the back corner there, those are birth defects. You can make a map of birth defects by county in North Carolina, and they're going to be spatially distributed. I'd rather look at the map than just looking at a list of 100 counties. And we had a couple of former social work students. That's what they wanted to do. Yeah, I found this cool data, this interesting data set on birth defects by county. I want to make a map out of it to see if it's spatially related. So there's lots of reasons why joins may not work. And this is where your attention to detail comes in. Because at the end of the day, computers are stupid. They're going to do whatever you tell it to. So if you have something called Bladen versus Baldwin, and guess what? It's not going to match up because the computer says it isn't. One's capitalized versus one's not capitalized. Are there ways that you can take lower cases and make them magically upper cases? Of course you can. Okay. In Excel, we can do this. Equals, we already did these functions, right? This column plus this column divided by this column. We have something called upper, lower. Every function, every computer language has some sort of upper or lower function. What is it called when what kind of case is it called when the first letter is capitalized in each word? Was that? I think it's called proper, but it might be too. Proper case. But yeah. What would you say, Daniel? Camo? Okay. That works too. That sounds right too, yeah. Proper case, so we got proper case, uppercase, lowercase. So a lot of times I get frustrated when people go and, I'm going to have to, these things don't match up. I'm going to have to go and retype all the uppercase. No, you don't. And if you have to start retyping or start counting stuff, then there's going to be a simpler way to do it. We just got to figure out what that way is. One text is treated as text, another is treated as a number. A lot of times when we see things like FIPS codes, FIPS codes are 37063, kind of like your 820 number. Can I add up my 820 number and your 820 number and get something useful? No. Okay, no, I can't say my 820 number is better than your 820 number. I can say certain, qualities like, hey, my height is taller than your height or whatever. But I can't do that about 820 numbers because they're what we call nominal data. And so when we start looking at these data sets, we can start to figure out what are things that we can make calculations with, string calculations with. I was doing some interesting string stuff previously. Also file formats. I like working with CSV files, comma separated values, and I think we talked about those last week, where if you were to open up the Notepad or Word, it would just be separated, literally separated by commas. Wherever it sees a comma in Excel, it just moves over a column. So I think we ran into a couple of issues when I was working with some of the PhD students where the column names were a little bit funny because I think there was a comma in one of them. So it just said, all right, I see a comma here. I'm going to move over a column and go from there. And just move over. So the column names was called 5 concentration, probably because there was a comma before the number 5 as part of the name of something, which was really unintentional. Also with file formats, ArcGIS doesn't like Excel at times. And so it's got these, little dollar signs that are part of the name. And so it might start to yell at you because it doesn't like dollar signs as names. So we export them to DBF files or even better CSV files. I really like CSV. I've been kind of doing pretty well with CSV lately. Another thing you notice, if I type in word Bladn, B-L-A-D-N, enter is different than B-L-A-D-N space, enter. Those are tough because you don't notice that space there. It's literally a space, and so I've seen a lot of Excel issues where people type in a space and hit enter and say they look the same, but they're not the same because these computers are going to do whatever you tell it. And also the computers are going to do whatever you tell it, so if you put a space after Bladn, it's not going to know that you didn't mean to do that. So we run into these instances. Now, spatial joins, we're already experts all at spatial joins by now, right? We count the number of cancer deaths by county. And typically they're related to containment and proximity, but for me, containment, this is the main thing that I work with. I want to count the number of crimes within each block group or police beat or whatever. I've got people across campus want me to make maps or whatever. I might have to pass it off on to Andy or something like that, doing some spatial analysis maps here. But containment and proximity, these are relatively easy maps to make here. We've got some spatial joins with tornadoes and the GIS data layer of states where that we can run a select by location if you got here in Pennsylvania, New Jersey, Connecticut, Rhode Island, or whatever. But we can also run a spatial join that does the same thing as well. And spatial join. And so this is what my tornadoes look like. There's 1,565 of these tornadoes. And I want to count these by state. And I'm going to run a spatial join. And while I'm doing it, I can also add up the F scale or the number of fatalities or the number of injuries, just like we did for the data we were looking at. Hey, let's find the standard deviation. Let's find the mean of all of these. So we can run some really insightful statistics or meaningful insights from these as well. So in this case, the key is location. The reason why I'm talking about these is because I'm leading up to the idea of normalization, meaning if I'm just mapping tornadoes by state, guess what? Probably the biggest states are going to have the most tornadoes because there's more of a chance of them happening there. So I have states tornadoes, which are my join features. So when I run the little tool right here, I can just right mouse click, and then I can run my join target features, my statistics to compute, and my brand new data layer. Now these days with spatial joins, it doesn't create new output feature classes. And those are some of the nuances that you'll start to see of ArcGIS 3.3 as opposed to 3.0 and 2.6 and 2.7, where that it might just add brand new features at the end of that join instead of creating brand new feature classes. Okay, so be aware of software. Right now, I'm working with IT to get the latest and greatest GIS software installed on here, but I'm stubborn and I'm kind of working with the old software, so you might see some slight differences between the two, but it's not that different. So what do we do when we run a spatial join? What do we do when we ran that cancer? In exercise one, you all hit the ground running. You ran like spatial joins day one of geostatistics class. What'd you do? You counted the number of deaths by count. Now, what we're going to start doing next week is we're going to do the same thing, but now we're going to figure out which one has the highest death rate, because I bet you Mecklenburg, Wake, Guilford, Durham, are going to have the highest number of deaths. And most people are going to say, no, of course that makes sense because there's so many people that live there. And so we're going to start to get into calculating columns, and more particularly, we'll talk about those next week, calculating brand new columns so we can calculate death rates. And I think we're going to do it in our exercise because I want us to take a long time to get into the exercise, the hands-on exercise, I call them case studies, to look at like diabetes and heart disease related death rates. So we assigned each tornado to a state. We counted up the number of tornadoes by state. We added up the number of fatalities and injuries by state. And then we ran into null. What's this word null mean? Literally like nothing, like not zero, nothing. There's a difference between zero and null. Right? A lot of times people see null, they kind of substitute it with zero. Zero is the number that we average out. Null is something that we try to remove from calculations. And so when I run the spatial join, instead of getting this big nasty map here, I get a map that says join count. 93, 127, 343. Does that ring a bell with frequency? Same exact thing. So frequency of 242, that's how many readings we had for that particular exact latitude, and then another for another latitude, another for another latitude. So the results of these are all relatively easy to interpret because we have these really powerful tools and we run them, and then people have trouble kind of making sense of these or clicking the wrong buttons or whatever. So I really want us to be aware and be able to interpret these results. So in Rhode Island, there are 9 of these points in Rhode Island versus 81 in New Hampshire and 37 in Vermont. And then while I was at it, I went and added up all the injuries and all the fatalities and then other stuff I couldn't, like F scale and damage. I didn't really care too much about. I don't want to say not care too much about, but I wasn't worried about it because they changed some of the notations for this. So you can see in Pennsylvania for these tornadoes, there were 46 total fatalities and 1,016 injuries from the records that were kept between 1850 and whatever, 2015. So these are really powerful insights. So now I can make a map like this, number of tornadoes. Pennsylvania and New York are really high. Why do you think they're so high? What could be one of the reasons why they're so high?
They're a larger state.
What'd you say, Greg?
Oh, it's Cameron, but they're a larger state.
Okay, yeah, exactly. They're bigger. So there's like someone was saying, people. Now with people, it's typically going to be with like crime, homicides, things like that, death rates or whatever. People might not have as much an impact on tornadoes, but these are big states. So there's more of a chance of you having a tornado here as opposed to there. And this is where we kind of lead into density. Now, when we went and made maps, I'm sure you might have noticed, we have a little button there. We did symbology. We had a little button that said normalization. You put a little button and you can normalize it. That's all we're going to talk about today. Now, this is the total number of deaths. In Massachusetts, there was some really big tornado that had like 46 deaths, so that pretty much accounted for all of the deaths. And then things like average number of injuries per tornado. But what we want to do, if we were to map the total number of tornadoes, like Cameron alluded to, larger states are going to have the potential for having more tornadoes. So what we want to do is we want to calculate the number of tornadoes per 1,000 square miles. And so for something like, I don't know, Rhode Island. Rhode Island had, 9 tornadoes. And what was the size of Rhode Island? It's about 1,000 square miles. I have to code it needs to be. Yeah, 0.009, right? If I'm not right. 0.009. What are the units? Tornadoes per square mile. That's what we talk about here with the colonizations, the decolonization. I just, my involved is going to miles. How many people work with miles in their life? People outside the US work with kilometers. So I probably need to do, I need to do a better job of making sure we have units that are going to be by everyone, or understood by everyone. So, but why don't I want to make these per square mile? How do we measure homicide rates? Do we do number of, deaths per person, deaths per capita? How do you measure crime rates? This gets really deep, really quickly. Per 1,000, why per 1,000? It's equal, it is equal, so it's the same, but what does a 0.009 tornado look like? I know what 9 tornadoes for every 1,000 square kilometers, 1,000 square miles looks like. Same as homicide rates. 1.3 homicides for every 1,000 people is the same as 0.0013 homicides per person. What do? I just move the decimal point over so I can work with units that I'm familiar with. I know what 1,000 people looks like. I know what 10,000 people looks like. 10,000 people is pretty much all students, faculty, and staff on campus. So we have 1.3 homicides for every group of NCCU community, group of NCCU community compared to some other place which is 2.3 or another place which is 1. And so we put them into units that are a little bit or a lot bit easier to understand. Other things about normalization, I see these things here. I see heroin-related deaths in North Carolina. I always kind of like looking at the newspaper when they used to come out with newspapers. And what am I looking at right here for heroin-related deaths? These are all the most populous counties in the state, right? Now, some of these are going to be useful if we're looking at certain things. Normalization. Is mapping the total number of tornadoes the best idea? No. Larger states will have the potential to have more. And so kind of going back to this, because there's always going to be some guy or girl in the back of the room saying, did you think about this? And so we're going to talk about some of the caveats related to that. And so what we're going to do today, and we'll take a quick break here because I do want us to get out not a little bit early, a lot better early, so we can finish up exercise 2, and then I can kind of get to sleep before 11, is that we're going to create brand new columns, just like we did in Excel. Didn't we create new columns in Excel? And what did we calculate? We calculated z-scores. You put a little equal to sign, you drag stuff down, you put in equal to signs, means, little dollar signs to keep stuff in place. We do the same thing in ArcGIS Pro. Now we need to be aware. Now Excel is pretty smart, or Excel thinks it's smart. In ArcGIS Pro, it kind of leaves it up to you. So we're gonna have to start thinking of things like what type of precision, how many decimal points, we have single, floats, double, all this other stuff right here. And so we'll talk about these a little bit more because now when we look at a map here, we can look at tornado density and we can say like New Jersey, Connecticut, Massachusetts, you have a higher chance of being in a tornado if you live in these states as opposed to these other states. Now, what are metrics that should be normalized? What are metrics that shouldn't be normalized? And kind of, this is just a quick summary right here. I want to give a quick summary of things like, instead of mapping cancer deaths, let's look at the cancer deaths per 100,000 population, or more specifically, age-graded cancer deaths. Instead of number of tornadoes by county, number of tornadoes per 1,000 square miles by. And we can just calculate a nice little formula that does that. number of deer vehicle sightings per census tract, number of deer vehicle sightings per quadrant. And later, we're going to start getting into quadrants as well. Quadrants are basically equally sized squares. So equally sized squares, say they're 1 square mile. If each of these squares is 1 square mile, then we have to calculate, and we calculate the number of deer vehicle collisions with each one. We have to calculate the density. Why not? Because they're all the same size. So this is 6, this is 3, this is 2, this is 0, this is 5. It doesn't matter. They're all the same size. Now, that doesn't exist in reality because there's going to be some phenomenon where I can do this, but I don't know how many people live in each of these squares because they're collected by counties and census tracts and block groups and blocks, which all have these really odd sizes that I don't really know why exist. Total number of highway distance by state, highway distance per population. Total income by county. So we hear these words like mean income, median household income. Population change by county. Hey, this county gained 14,000 people. Is that a lot or a little? County has 2 million people in it. It's not really all that much. So we can look at things like percent population change, new minus old divided by old. Or median monthly rent per household by census tract. So really think of ways to normalize the metrics that you're looking at in your research. That's really important because a lot of times we see these no-doubt questions. Yeah, of course, there's lots of AIDS mortality in that county. There's more people that live there. Now, if we were to look at these rates, now we can start to see why or how or what factors lead to this. So how do we normalize this? These are EOG scores. Okay, so these are EOG scores by school. And so we had a former student, and they just mapped EOG scores by school. So these bigger schools, these bigger dots were schools that had higher non-passing rates or higher failure rates than other schools. This is high school graduation rates. Okay? High school graduation rates, red lower, green higher. These are percentages. This is prison reentry. Look at that. That's just a big old map. Can you make sense of that? You make sense of that a little bit better, right? Okay. Big map, easier map. So number of prison reentrants per 1,000 people. And so some of these here, 0 to 3.4. So for every 1,000 people, between 0 and 3.34 prison reentrants live there for every 1,000 population. Now, the one thing a map does, maps like this do we know the exact value right here? No, it's a map. We smush the data, which is unfair. But we have the GIS data running in the background, so I can click on it, and actually something pops up with the rate or whatever. But these maps are really gross, or not gross generalizations, but they're generalizations that exist with these. Child maltreatment rates. So you can see child maltreatment rates. It's really low in Watauga County. Why is it so low in Watauga County? What's that? Well, these are rates. What's that? Older people. Actually, these are younger people. So these people aren't old enough to have. There's not that many kids. So much younger population. So there's probably not that younger people. But this is spatially related, which I thought was kind of interesting. Child maltreatment, which you think is a stochastic or random phenomena. There's a definite phenomena here, which ranges, from 17 all the way up to 110. So these high counties have like 5 times higher child maltreatment rates. And in this case, this kind of talks about where I got the data here than other counties, which I think is really interesting. Other things we see here, alcohol, heroin related to this, fentanyl, which is getting big these days, unfortunately. So we can see, some of these maps right here. Opioid deaths per 100,000 people. Now my newspaper starts to kind of, make the rates out of these here. So now maybe some of these rural areas are starting to get vetted out a little bit more now that we see the actual rates attached to these as opposed to some of the raw numbers. And then the other thing that we have is like the COVID-19, there used to be a big COVID-19 dashboard where we made maps, which gave us the cases per 10,000 residents, cases per 100,000 residents. You can just see it moved over a little bit and the number of deaths. But the last thing that I think is interesting is age grading. And this is a map here, and this is what the PhD student named Alana that we worked with. We wanted to kind of combine some of her wet bench work with some of the work we were doing here, is that when you make a map here, and these are raw cancer mortality rates. When you make a map here, you're basically mapping where the old people are. And there's a really good primer right here created by someone in North Carolina related to this. To me, this is part of our paper right here, so I'm really proud of this here. But I want to bring up this this primer, and so this is the primer for the state of North Carolina, but this is age grading because, like I said before, you know, not older counties, but where older people live, are going to have higher death rates because older people have a higher chance of dying than younger people, right? It's kind of self-explanatory here. Now, we create something called age-graded death rates. And if you were to look at the little formula right here, we have something called the direct method here, but you see this formula right there? What's this formula here? What's that little symbol right there? That little sigma notation mean right here? Sum, add them all up. So we had 10 different age cohorts, 2, 4, 6, 8, 10, 10 different age cohorts where basically what we do is that, look at this, we have an age-specific death rate and the percent of population in each group. And what we do is we basically multiply this times this, add it up to this times this, add it up to this times this, this times this, this times this, and then divide by 100. What are we basically doing? Can we just divide up by, what if we were to average all these up? What would happen to this rate if we would just average all these up? It'd be really high, right? But what sticks out to you? That 133.41. But the thing about that 133.41 is that only 1.6% of the population is age 85 plus, even though 133 out of 1,000, like 13.3% of them, die over this time period. So what are we basically doing? When we run age grading, we're running just a weighted average. Right? Calculating your GPA. All you're doing is just calculating your GPA, where that we have an age-specific death rate times what? What's the weight? The percentage of people who live in this age group. So this age group here, 35 to 44, make up 14%. They don't contribute that much to, or they contribute more. Their 3.64 contributes a lot more than this 133.41. Now, the trick is you got to do this for every single county. Now, the GIS runs it for, we can run that sum calculation thing for every single county, but what do you need to do? For each county, you got to get ages 0 to 4, 5 to 14, 15 to 46. And then you got to break down all the people who died and then calculate the rates of people who died at these particular ages. Now, that's going to be hard to do over like a 1 year period because how many people might die in a 1 year period over age 0 to 4 in a really rural county? 0, 1, or 2. And especially when you start looking at like particular ailments, it gets really ugly really quickly with these data. And so age grading is kind of I don't want to say a lost art, but it's an art. Because we have census data. This census data is really good to us in terms of, I know how many people are each age. It'll probably take, and someone like Cameron who's gone through and kind of extracted these data by hand, it'd probably take a half day to figure out All right, let me go get all the data for people age 0 to 14, 5 to 14, 15 to 24, 25 to 30. It's pretty easy to find all those. A little bit laborious just to make sure they line up and get the GIS data. I know Kimberly and Mary and Philip, we started to work on, well, we're already not giving you the data. You are creating your own data. And I think we're starting to appreciate some of the challenges it is to create and make your own GIS data. And this age grading, I think, is really, it's neat. It's necessary. If you do any sort of like research, especially with like National Institute of Health, you're gonna have to sit down and do some of this age grading. But I want to stress it because this is what, oops. This is what the age grade rates look like here. So this is what the more actual mortality rates, when we calculated the number of cancer deaths per 10,000 or per 1,000 people, this is what you get. You're basically mapping where some of the old people are, a lot of old people out there. So we run this function right here, and this is what we wrote. So now when we run it, kind of changes it a little bit. This is the age-graded mortality rates. Now we run into major issues with like small number of problems and all this other stuff right here. So this is the age-graded rates, and then from here we went and ran some cluster maps and all this other good stuff. So let's take 10 minutes. We're going to start something called case study number 1, where we're going to just kind of calculate the total number of deaths by zip code, the death rates by zip code. We're going to run something called summarize, and then we're going to run something called the join. People already know what the summarize means. And then we're going to run something called the join, and then we're going to revisit this. We're going to revisit this in a couple of weeks when we go back to looking at change detection. Well, actually, we'll revisit this next week when we get to something called change detection, which means how much has it changed and what are some strategies and methods by which we can visualize change? How do we map change? How do we, at the end of the day, what do we want to do? We want to do what? Assessment and evaluation. What does assessment mean? What's evaluation mean? What do you want to do? What does assessment mean? Everyone loves these terms. And the grant stuff that I write, everyone loves assessment and evaluation. What's it mean? In this class, you're going to have to do some assessment and evaluation. Exactly. Take an exam, that's an assessment. An evaluation is interpret the results. So in this class, I've got my statistical tool. And then how do I interpret the results? Assessment and evaluation. Hey, there's a relationship between COVID rates and distance to proximity to chicken processing. Okay. So let's come back here at 6 o'clock. We'll kind of go through this. Hopefully I can get on the road by about 7 or so and get my head down on the, get my head down on the pillow. So start fresh tomorrow. So we're gonna open up case study 1. So let's be back here at 6 o'clock and then we'll start working on that. And we'll kind of look to answer some of these questions here.
Okay. How much of it do you have? Okay. That's how we can do it tomorrow. Have to be here when no notes. That's good. I think that it's like, if we over at the end of the week. No, it's so horrible. I mean, I was like, I was just, help them understand that the behind the scenes helps me understand more than. Right, exactly, it's a kind of. So well, I'll talk to her, I'm like, wait. That was just really good, but. Oh. I think he helped him back. He's not going to do work.
Orames.
Over us. We see you looking for him. You know.
So what, Kim?
Any good with it? No. Yeah.
So what?
Eh.
How y'all doing? Huh?
Oh, it's just that day.
What happened? Mary, can you hear me? Kim, can you hear me? Good.
See, so. Finish up some.
We have to do, yeah, I don't know. Yeah.
No, I'm not. I was good, okay. You know.
All right, we're back here. We're back. Hi. Okay, couple things I'm gonna point out today. We're gonna do it all together, or you can start doing it now. We're gonna open up something called case study number 1. It's a table of all coronary disease deaths between 2011, 2013 today. And we're gonna kind of focus on this next week as well, when the map changes, that we're gonna map the total number of deaths by zip code, and then we're gonna map the death rate, and we're gonna start to figure out what issues we see. Okay, also, I want to mention, and I said we got a couple weeks to do the homework, but exercise 3, we're gonna kind of open up, and you can open up, it's not gonna be for 2 weeks. So exercise 3 will be doing 2 weeks, but there's a 3A and a 3B. Where basically you kind of do the normalization with one, the change detection with the other, is that you're gonna create a normalized cancer death rate by county. Have you already done the number of deaths have you already done the number of deaths? Yes. So all you need to do is create a new column and then divide by population, multiply the whole thing by 1,000. right? Move the decimal point over 3 places, that's all you're doing. So we're gonna calculate those death rates with a different project in class, hopefully you can apply those. Also, if you really wanted to, one person has done it before, if you want to make an age-graded map of exercise number 3, you don't have to take the midterm and you get 100 on it. You probably do more work doing this than taking the midterm, so, but, yeah, it's like projects, project, you put in more time in the project than taking the stupid test, you know what I mean? Like, I don't use the word stupid, facetiously, but I just need something that kind of shows, because you might be good at writing papers, you might be good at taking tests, you might be good at readings. I don't want to be all of maybe, I don't want everything to be based on one thing, so I kind of offer a kind of a hodgepodge of different assessment evaluation techniques. But if you can make a map, age graded map, okay, so each county is going to have a raw death rate, and then it's going to have an age-graded death rate. Raw death rate, age-graded death rate. Because when you map the county death rate or cancer death rate, it's going to be really high in the West. Why? Because that's older population. And so when we move that, it's going to really move the needle. And so all you're going to do is follow the techniques that we talked about and do it. Because when we start looking at the data, when we start looking at the zip code data that we're going to look at is the same as the county level data. It's what we call SF1 data, short form 1 data. It's the information that everyone answers for the census. So things like age, race, who you live with, housing status, not income or anything like that. So it's got the people age 0 to 4, 5 to 9, 10 to 14. So now you can start to figure out those age-specific death rates and then the percentage of people who live within that age group. Okay, so you're thinking that you're going to have a lot of columns, because today we're just going to calculate one brand new column. For exercise number 3 or 3A, you're just going to calculate one brand new column. With this one, you're going to calculate a lot of columns, but it's going to be quote unquote right. Okay. And we're going to start talking about some of the real world issues that you run into that we have problems with. Something like the small number problem. Has anyone heard of the small number problem? And don't raise your hand, Chima, because I know he. But if you happen to have a zip code that have four people living, and one of them dies, does that really mean 25% of the people are going to die? No. It's just a happenstance of that singular event. Or counties that go from 1 to 2 deaths, especially when we look at things like infant mortality rates, especially something like African American infant mortality rates in the western part of the state, since it doesn't have a relatively high African American population. If it goes from 1 to 2, it's doubled. I'd be a lot more concerned if it went from 100 to 200 than if it went from 1 to 2. And so you got to think about that. Or how do I address those? Am I going to just put little, not show those or whatever? So those are kind of bigger picture things to think about. So someone who's been doing this a lot longer than you or I say, hey, let's revisit these data. All right, but for now, we're going to look at case study number 1, and we're just going to do some of the techniques I was talking about with some of our PhD students, and we're going to kind of extend them to here. So what we're going to look at, we're going to look at the modules. We're currently in week number 3. Where's case study number 1? Okay, good. All right, I have it. I thought I messed something up. All right, so we're going to look at case study number 1. You notice I've got like exercise number 3 next. You can open up exercise number 3. So we got case study number 1. Make sure you're all following along right there. Okay, and let's download it. Now remember, so we can download this thing here. And I'm gonna go to my downloads. Okay, you can see case study 1. I've already downloaded it a couple times. Now remember, this is a zip file. If I click on something and it says extract all, what do you think the computer is telling you to do? Extract all. Okay, so this is a zip file because I don't want to put all the files into one, so they're basically compressed. Okay, so I'm going to click extract all. Where do I save it? Save it wherever you want it. Save it to your geography 34, EASC, Geostats folder, whatever. For me, I'm the next person, so I'm just going to click wherever it is and then complain later that I can't find it. Yep, that's what I'm going to do. Okay, but save it in a place where you know you're going to save it, documents or whatever. Me, I do this stuff all the time here, so I'm going to click next. And now here, I'm on case study 1. You notice there is not an extract all right here. So now this means that it's extracted. You also notice the little icon isn't there. You notice the little icon, it's got like a little zipper right there. No zipper there. So now I'm going to go to case study 1. And then I'm going to open up the APRX file. It should have this little blue folder. If it's got the little blue folder, that means that you've got ArcGIS Pro installed onto your computer and it's ready for it to be opened up. And what we're going to start looking at is just real life raw data that you're going to deal with. All of these exercises that I've given you, they're like, you got to do a couple things here to make some sense out of those. And with some of the PhD students in our little rotation that we were doing was like, you're starting the map from scratch. You're not even working with an APRX file. You're making the APRX file yourself and then going through and adding data. Now, what are we looking at here? I have study area of different counties, and I've got zip codes. So what we see here in our table of contents, and our table of contents is to the left. Okay, does everyone have it open like this? Can everyone see this? Just making sure. Okay. See a lot of people nodding their heads. Okay. You all set, Michael? Yes. Okay. I assume everyone's looking good there. Online, good. All right, so I've got my counties, and if I were to just right mouse click and open the attribute on my counties, you can see some of the data attached to counties. I've got population 2010, population 2013, age under 5, age 5 to 9, age 20 to 24. So we got like different percentages of people in different cohorts so that you could extract out the deaths at those ages, figure out a age-specific death rate, and then calculate and weight it by age. Because all you're doing when you're creating age-graded death rates for each county is you're just creating that GPA. That's all you're doing. It's a little trickier, a little harder, but that's all you're doing. Okay, but it's going to be necessary. You do any type of demographic research, it's going to be necessary. Okay, and so you can see everything that I've got right here. Okay, next I've got the zip codes in my study area. So I can right mouse click, zip codes, open attribute table. And what do we see here? I've got a post office name. I've got a zip code, a post office name, a state, and the POP 2010. We're just going to work off the POP 2010. These days, they don't publish these data as much. The POP 2020 data just kind of came out. So all this is all we see here. Now, one of the weird things you see here is that the zip code is left justified. POP 2010 is right justified. Does everyone know what the word justification means when we talk about tables? Where it lines up, where it starts. Okay? So right justified, left justified. Did ArcGIS Pro just decide to do one way, one the other? No, definitely not. Why? Because there's nothing random or specific. So anything that's left justified, these numbers that are left justified are text, right justified are numbers. Now, these numbers could be integers, they could be floating points, decimals, whatever. Okay, so left justified, so this number isn't 27,209, it's really 27209. So if the zip code started with a 0, like my zip code starts with a 0, it's gonna start with a 0. Okay. Next, I've got my standalone tables. These are all of the people, the 35,401 people in the state who died of coronary heart disease. And basically, all I did was I extracted out certain ICD codes and then extracted these out for the entire state. And then if you go all the way to the right, I've got a zip code. You notice this zip code is left justified. So it treats it as a text. Now, what I want to do, you know what would be great? I want to make a map of all of the people who died by zip code just for this area of coronary heart disease deaths. That'd be pretty cool, wouldn't it? Now, the trick is, and I'm going to pick on 3 people specifically here. Okay. How do I count the number of deaths by zip code? What do I do? Count the number of deaths. I want a big table that says 28170, 15, 28640, 27, 28615, 42. Create a join. On the right track. We need to do one thing before we create a join. What's that technique called? Summarize. Exactly. Now there's a neat technique called summarize, which counts the number of times something appears. And while we're doing it, we can do other neat things. You know, we can average up the age, you know, age of the people who died, because you can see 89, 61, 67. We can look at the, you know, we can count the sex and the race and all those other things. And we could probably leave this for another time. But under zip code, what we're going to do is we're going to right mouse click and we're going to click on summarize. So we're going to click on summarize. And all we're going to do is just count the number of times each zip code appears. So I'm going to have something that says 27358, 22, 27845, 27. And now, like Philip alluded to, I can just run something called a join. So now the case field is going to be my zip. I can run other statistics if I wanted to. While I'm here, you know what I'm going to do? The age in years. I'm going to click mean. I can run lots of different statistics. So what this is going to do is for everyone in the same zip code, I'm going to average up the age at which they died. Now, we just were working with some PhD students a couple hours ago where we did the same thing, but we summarized each station. We downloaded 5,000 PM readings, and we just summarized by station and said, hey, for each station, while we're summarizing it, we're going to get the mean, we're going to get the min, we're going to get the max, we're going to get the range, we're going to get the standard deviation. So we can map a number of different descriptive metrics related to each of the stations. Hey, which stations have the highest range? Which stations have the highest standard deviation? Which stations have the highest mean? So we can look at which one has the most variability, which one has the least variability. So I can run a lot of different, if I really wanted to, those age in years, I can run the standard deviation, meaning does it have 14-year-olds, 100-year-olds, you know, dying of heart disease deaths, or are they all 62, 63, 68, 64? You know, it might yield some useful, I don't know. You know, and the only limitations we have here are your imagination, really. Your imagination are the only limitation. Okay, so age and year. All right. And we're recording here, so if you want to come back and revisit this, hit the pause button. Okay. And so my case field's my zip. My age year is going to be, well, I'll just click on mean. Because, you know, I can also do like set, you know, I can do lots of things here. And I'm going to click OK. All right, let's see what I got here. I got my statistics. All right, what do I have here? I have a bunch of nulls. All right, what's that mean? It means a bunch of them didn't even have data with them. But under frequency, I'm going to sort descending. What does this frequency mean? How many times a zip code appeared from the heart disease death rates between 2011 and 2013? Now, I'm sure Cameron can attest that it took a little bit of effort for me to put together all the death rates from 2011 to 2013, query out the ICD codes related just to those death rates. Now, you see here, I've got 1,600 zip codes. Do you think there's 1,600 zip codes in my map there? So all we're looking at here is 28655 had 295 deaths. 28645 had those. Had 253, 243, 229, 223. Okay. I guess I gotta pick up the names. Okay, and Olin. All right. All right, we can see the mean age and years there. Okay, now we've got zip codes here. Now, like Philip said before, I was talking about all this join stuff. Guess what we're gonna run? We're gonna run a join. And all we're gonna do, these zip codes, because watch what I can do here. I can click, this is a GIS map here. So all I want to do is just put this frequency, this is the standalone table. What's standalone table mean? Table not attached to points, lines, and polygons. I've created some, I use the word geopotential. I'm trying to market that, but geopotential, it's got the potential to be put into GIS, but it isn't GIS. Okay. So basically, what I want here is, I just want another little column here that says frequency, and then maybe another little column here that says rate, so I can map the rate and we can get out of here. And so we're going to run something called a join. Okay, this isn't a spatial join. I've already kind of threw the spatial join at you in the first week of class. So now what we're going to do here in zip code study area, I'm going to right mouse click, and I'm going to click on join. Joins and relates. And I'm going to click add join. Okay, so my input table is my zip codes in study area. What's the name of the table that I went through the trouble of creating? This is the one with the statistics. Now, we can give them nice, pretty names and everything, but you know me, I just like to click next, 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 figure it out later. Okay. So now I want to join it to the coronary heart disease statistics. And then the join table, the field is going to be zip. So in one, it's called zip. The other is called, this is real easy. Sometimes it's called zip code and zip or code or whatever. Lines up nice and neatly. Just for the heck of it, I always like clicking validate join. I'm just going to run it right here. Look what it does here. It says 1-to-1, a match has been found for 80 records. The input table has 82. The join table has 1,613. Now, this statement right here basically says, hey, you went through the entire state and found there were 1,600 unique zip codes that had deaths, but I only found 82. Now, what's the significance of 80 or 82? That's the number of zip codes in my study area, in my 10-county study area. So basically, what's it doing for the other zip codes? Don't care. It's not going to include them. Goodbye. I'm going to click close. I'm going to click OK. And to me, this is like the magic here. Look what just happened. Here's my brand new attribute table. The zip code, post office name, state, population. This thing's called Object ID. Object ID is just something that ArcGIS Pro uses to uniquely identify the objects on the map. And now what do I have? Zip code, frequency, mean years. This is what we just did here. So a couple minutes ago, we were sitting there with a big list of everyone who died of heart disease in the state between 2011 and 2013. Now we're able to map it for our 82 or 83 zip code study area. Can you make a map out of this? You bet you can. Let's right mouse click, go to symbology. Instead of going to single symbol, we'll go to graduated colors. Frequency. Look at that. Okay. And those of you following along or following along later, I've got the field frequency. We'll come back to normalization. These are different ways that you can break up the numbers or classes right here. And then classes and colors. Me, I'm a big green. Does anyone know why I like the greens? Great color gradient. There's a lot more internal contrast in your greens and your purples as opposed to your blues and your reds. Okay. Even this one right here, I don't know if anyone noticed this one here. You're starting to have trouble between like the fourth and the fifth red where that we throw in a green or a purple. You can definitely tell the difference between the first green and second purple. You know what I mean? Okay. Me, I'm just a big green and purple person. I just want to prove myself right anyway. So we got a map here. Now, what are we looking at here? These are the zip codes that have the most number of deaths. Those of you sitting here looking at this map are going to say, what? I bet you those dark ones probably just have the most number of people, right? Maybe, maybe not. Let's see. Now, we've got another button here called normalization. I can normalize by pop 2010. I just did. Wow. You think this is an accident? Normalized by population. Where did it move? Where are the highest death rates? Are they all scattered around? They all moved down here. What county is that? Is that Sampson? Bladen County. You think it's an accident that all the zip codes that happen to be really high just happen to be located in that county? I don't think so. Something's going on there. Might be health, diet, access to transit. It could probably be a lot of genetic, environmental, social, transportation, lots of things here. You know, and it's not, you know, I don't say it's not my job, but that's a bigger question for another day. Look what we got here. Really, really neat. This is powerful. So we can extract all these folks, rates. Now, what's the other thing? Maybe Bladen County, they're all just old. Yeah, I'll kind of leave that question for next week when you look at some of the cancer rates. But the last thing I want to do is I want to be able to, before we leave, I want to add a new column here. And so instead of me kind of doing this on the fly, because what are these units right here? 0.00812, 3.0063. What are these at the end of the day? Deaths per person. Do you understand? What does 0.008 deaths look like? I don't know. I want to look at deaths per 1,000 people. That makes sense to me over this time period. And so what I'm going to do here is I'm going to go and add a brand new column to my zip codes, just so there's a little bit more permanence there. A little bit more permanence. Okay. So I'm going to click this. They call them hamburgers. I don't know what they're called, hamburgers, but click this little hamburger to the right of the table. And then these are all the things that I can do to the table. Field view, joins and relates, find and replace, go to row number. I'm going to go to something called fields view. Now, if you look at this fields view, what do you see? Pop 2010, Pop 2013, white, black, American, you know, all these here. Why can't you see them in my table? Because I unchecked them all. Why do you think I unchecked them all? I didn't need them. I just wanted to make it nice and simple for the exercise. So I didn't want us to look at every single one of these here. You know, because if you really wanted to look at these, you could look at all these here. You know, I think I might have some like households, all this stuff here. Now, what I want to do here is I want to add a brand new field. That's going to be part of this here. So it says, I'm just going to follow the directions. Click here to add a new field. Okay, cool. What do you want to call a field that represents death rate? What do you want to call it? Something that you'd understand. Was it? Death rate. Let's call it death rate. That's fine, yeah. So we're going to call it death rate. The alias, we don't need an alias. Now, data type. This is a tough one here. And a lot of times, the default was long. So these are basically, what type of number can death rate be? Can it be positive? Can it be negative? Does it have decimals? Probably, could be, yeah. There's things like Pop 2010. Does Pop 2010 have decimals? Yeah. Pop 2010, does that have decimals? No, it doesn't. Can you have 2020? Yeah, you can't have decimals. And in the computer world, when you start storing numbers with decimals and negatives, it takes up a lot of memory and space. So basically all these things are like, how much space do you want to save? And so shorts and longs are for integers, numbers that don't need decimals, like Pop 2013, month, 1, 2, 3, 4, 5, whatever. Floats and doubles store decimals. Floats are for smaller decimals, doubles are for bigger decimals, because they care about space. These days, you know, I lose 64 gig flash drives in my dryer. I just find, you know, just flash drives laying around the house where my first computer was 8 gig. You know, 8 gig computer, first one in 1995. There's probably 8 gig flash drives laying around this room here in my office that I don't think of. You know, so space, we care about space. So it cares about all the ones and zeros you use to file size and all that. We also have things called dates. Obviously, a date is used to store a date. Text, you know, the name of a county, your 820 number. Because an 820 number, if your social security number starts with a zero, what's it gonna do as a number? It's gonna get rid of that zero. What do they call ghost zeros or something like that? It's gonna get rid of it. Okay. Blobs, widths, rasters, those are things that are slightly different. And so here, we're gonna click on double. And then up at the top, we're gonna click save. So now, when we go back to zip codes and study area, I've got my original table. I got all those fields that I unchecked so we didn't bother to see. I got my joint table right here that we extracted using our summarize function. And now I got this brand new column called death rate. How do you calculate the death rate?
So if you click save, you said you click on save.
Should be the up in the middle there. No, click on. It's right there, it's gonna say short and then click save. Yes. Yep, when in doubt, just force it to. Or, because when you X out, it's gonna say, hey, you changed something, are you sure? I'm sure, yeah, I'm sure. Okay. So we got the death rate. How do we calculate the death rate? Because I could put in these brand new formulas like we did in Excel, but if the formulas are garbage, then guess what? It's gonna be wrong. How do you calculate death rate? Just think of this in Excel. And I want it per 10,000 people. How do I calculate rate? What columns am I gonna do to calculate the rate? Frequency. So it's just gonna be what? The column called frequency. What's the other column that we divide by? Not average, forget about that average for now. Population, good, Michael. Pop 2000, we'll just do pop 2010. And since it's per 1,000 people, what are we gonna do it? Just multiply the whole thing or multiply the top. 1,000, that's all we're gonna do. Hope everyone can see that. That's all we're gonna do. So now, we're gonna we did this in Excel, right? We're calculating z-scores and new columns. In a few weeks, you're gonna be doing Poisson distributions in Excel, so. All they are just random distribution, a big fancy word for just saying a random distribution given this average. It's nothing to be scared of. Okay. All right, we're almost done here. All right, so death rate, right mouse click. I got sort ascending, sort descending. Oh, it's got a whole bunch of nulls here. What does null mean? Nothing. Why are they all null? Because we just went through the trouble of creating it. So custom sort, I'm going to calculate the field. So I can generate some code in Python or VB script. It gives me a couple of options, I guess, right? Or Arcade. I'm not as familiar with Arcade. So zip codes in study area, death rate equals what? All right, I'm just going to click on the frequency times 1,000. Now, who put those exclamation points there? Divided by, who did that? Who put these little exclamation points there? Did you? Did I? Am I smart enough to do that? No. So it knows when it sees those exclamation points, it knows it's referring to a field. These little dots, these refer to the tables that it's in since it's joined, since it's a combination of two different tables. So we're talking about a field in one table, a field in another table, because to us it looks like just one table, but it's really a joined table. Now, I'm going to do this again one more time because do you think I'm smart enough to type all this stuff in all by myself? No. So this ArcGIS Pro makes this really easy. I'm going to go double click on what? What Mary said. I'm going to double click on frequency. Double click on frequency times what? Type in 1,000 divided by what? That field that Michael said, top 2010. Okay. So the field for frequency times 1,000 divided by pop 2010. Because all we're doing is just moving the decimal point over 3 places. Yeah. Yeah, if you were doing more robust ones, you'd need calc,
Can you put in certain the times? You put a space between.
No, I didn't. It does it itself. If it did, it probably wouldn't matter. What would be a number that makes sense before you even run this? Would we get one that was like, would we get a number like 5,000? Would that work? Can you have 5,000 deaths for every 1,000 people? No. Why? Because the most you could technically have is 1,000. Probably I would say your high is what? 50, maybe 30. I don't know. Can you have negative numbers? No. Can you have zeros? You can have some zeros. Okay. All right, ready? Let's do it. Oh, uh-oh. What did it say here? Warning, certain rows set to null due to error while evaluating. Oh my gosh. What does that basically mean? There's some nulls in there. All right. Why? Why are there nulls? No, there are no joins, right? So when I ran it, there was nothing to join. Why wasn't there anything to join? Because nothing appeared in the original table. Why? Because there were no deaths there. Now, when we look at it, Polk Army Airfield, Fort Bragg Military, how many people live on those places? They probably have what? Very small populations or minimal populations. But no one with that zip code died in that big table, so how do we get rid of those? Can we get rid of those? There's a couple ways. If I wanted to, I could just go type in the number 0. Another thing is I could just highlight these two. Okay, just highlight these two in the left right here. Just right mouse click and click on calculate field. What number do I want to give it? 0. Let's put 0 instead of null, right? Aren't 0 and null different things? But in this case, they're going to be 0 means it didn't have any deaths that appeared, so the death rate is 0. So I got a couple of zeros. Go from there. Do I want to make a map of this now? Is it going to look like the other one that I have? It's pretty much going to look like the same exact one that I have. So I can go to a high, you can see like 8.12. What do you see in the table of contents when I ran the on-the-fly normalization using my symbology editor? So now I'm going to right mouse click, go to symbology. Instead of frequency, we'll go to death rate. Why did it change? Why does the map look a little different? Yeah, normalization. Oh. Thank you, Andy. No normalization. All right, we're back. Andy got me out of a lot of trouble there. Okay. All right. Well, it'd be really silly if you normalize the death rate with the population. Why? Because it's already normalized. You don't want to normalize it's already normalized. You get into really ugly things. Now it largely looks the same. I was going to say it looks a little bit different because now we have a couple of null values that were previously null that weren't part of the calculation that are now zero values. So now, can you make a map out of this? Yeah. What are things you see? What are things you like? What are things you don't like? And I'm kind of done here, to be honest with you. I can invent some more stuff to do, but I gotta go to the supermarket. Do you like this? I do, for the most part. The age grading we'll deal with in all due time. But I like this. And the student that we worked with, Elena, this is what we did for the entire state for African American female breast cancers. And you know what else we did? At this scale, we went and collected information like income, median age, access to transportation, and start to look at all those population density and start to look at all those factors related to those. Hey, I bet you this area right here is probably low income. I don't even know what it is compared to the rest of the area. Is there a relationship between cancer deaths and income? Bet you bet so. Now we'll rely on public health education or some of the other folks out there to tell us why. I bet you these are probably more rural. Yeah, so access to adequate health care, probably better. Preventative health care, much better. But we were sitting here with a big old table of 35,000 people who died. How many of them we got rid of? We probably got rid of most of them. We were just focused on this study here. Now, what we're going to do next week is change detection, where we're going to look at this group of people. We're going to look at how much they've changed. What are the different ways that we can measure change? Okay, we can measure change in rates. We can measure just raw change. Like, hey, if you went from 6 to 12, you had a 200% change. It's pretty bad. Or 100% change, doing the math. So that's about it for me here. I want everyone to kind of finish up exercises 1 and 2. Readings due next week. And then what we're going to do, we're going to piggyback what we did this week with what we're going to do next week with change detection. So if you want to get a peek ahead and look at exercise 3, I think you can answer about the first half of exercise 3. And then hopefully by next week, I think most of the people who are kind of coming in a little, coming in on GIS with a little blind here, kind of get caught up with many of the techniques. And then we'll start kind of doing some more neat things as we start to lead into spatial statistics. All right, I'm done here. We'll see you all later. Anyone else have anything to talk about? No? Okay. I gotta go home. That's, all right, darn. Okay, all right, we'll see you all later. Have a good day.
Thank you, you too.
All right, see you one.
Thank you,
Bye.
bye.
All right, see you.
Thank you, you too.